All right, welcome everyone. So today we are calling it the return of the data scientist. And we're going to... Great, I'm glad y'all are excited about this. Okay, so just to set the stage, y'all probably have seen this article already about harness engineering. Raise your hand if you've seen this. Okay, so about half the people. So if you haven't read this article, I highly recommend taking a look. But what it's about is a team at OpenAI. They use agents autonomously for a few months to build some very substantial software internally. And what they did is using a harness to keep the agents on track. And when people hear harness, they usually think about specifications and unit tests. But one detail that's really important to look at is, okay, the harness also contains logs, metrics, and traces. So like the whole observability stack. And what I'm here to convince you of today is that the harness is data science, or at least a big part of it is data science. So, okay, let's take a step back. How do we get here? Okay, so let's look at ML engineering, data science 4 years ago. So we used to examine the data really carefully, look at the data, visualize it. Anytime you had a model or a prediction, you would be very careful to make sure you align it with human labels. You're very careful to use the right tool for the task. And when it came to designing metrics, we really take a lot of care to make sure those are aligned with business goals and the metrics made sense. AI engineering today feels like we've taken a bit of a step back in some places. So now, a lot of times, we're just using vibes. To know if we're doing the right thing, a lot of times we're just asking the model, another model, if it did a good job, or the same model. And then we're not putting a lot of thought into metric design often. We're just using an LLM to just grade something on a scale of 1 to 100, or just using someone's metric package off the shelf without thinking about metrics. And this is where people get into trouble. And it shows up a lot. You can see it because AI engineers often are scared of what they don't understand. And the data science-y pieces of AI engineering, evals and retrieval, those have died so many times I can't even count it anymore. But this talk is about evals. And so what we're going to talk about today is, okay, how do people go wrong with evals and what mistakes do they make, and how you can think like a data scientist to overcome those mistakes. And so we have taught over 4,500 people evals at lots of companies, and we've seen the same mistakes over and over again. So we're going to highlight the most common ones. And for that, I'm going to give it over to Shreya.
Great. Hi, everyone. I'm Shreya. I'm going to tell you 5 big mistakes that people make coming into working with us and how we can course correct it by wearing a data scientist hat. So the first one is kind of using metrics, what we call generic metrics or off-the-shelf metrics, to measure the accuracy or alignment of your agents. And it's tempting to use these generic metrics, right? After all, we use generic metrics for software. We measure things like latency or uptime. But AI needs a different approach. Even then, what are these so-called generic metrics? You might have heard things like helpfulness or hallucination or coherence. And yeah, they sound like they're important to measure. But when you really think about it, they're quite ambiguous, one. Can you really tell exactly what hallucination means? 2, if you're building Hamel is building an app maybe for a medical context, or I'm building one for a legal context, our definition of hallucination is going to be different, right? Maybe different tools or different data that's being used in these applications. And it doesn't make sense to use the same definition or the same way of evaluating hallucination or an off-the-shelf evaluator to do this. So how might we kind of circumvent using off-the-shelf metrics? How would we do this as a data scientist? Well, we would actually explore the data, look at what's breaking, and try to really specifically name what the failure modes are to our system. So more concretely, what we've found that's really useful is using tools like Codex or Claude Code or Cursor, AI-assisted tools to build custom interfaces to load up traces for your agent, actually read each message in each trace one by one, and talk about what might be going wrong. Pretend you're the user of your system, talk to your PM or talk to someone else and be like, what are the mistakes here? Write them down as open notes, which we don't show here. But then over time, as you build these collections of open notes, you can then categorize them into the bespoke failure modes that you need. So for example, in this a real estate agent tour app, maybe some of the bespoke failure modes were it was rescheduling tours whenever there was or they were hallucinating times for the tours, right? That's something very specific to the app. Hamel and I always say, look at your data, and this is exactly what we mean by look at your data. It's not just, oh, look at it and don't say or think or do anything about it. It's build your own interfaces and try to find failure modes and try to do this at scale. The second metric, or the second failure mode that we commonly see is really using LLM judges to try to figure out what's going wrong. Maybe you looked at your data and you found a failure mode, but then you simply go and ask an LLM, hey, how often is this occurring in my data, without any notion of trust in that LLM judge itself. So I'm not saying that using LLM judges are bad. I'm saying that using LLM judges kind of blindly without validating your validators is bad. So what do most teams do when they use LLM judges? Well, they ask an LLM, hey, I have this failure mode that I'm trying to measure. Maybe rate how good or bad something is on a 1 to 5 scale, and then give me the numbers. And then they kind of see this histograms of 1 and 5, and then try to make some business decision about that. That's not really good. We found that it's really difficult to trust those numbers or even turn them into actionable business metrics. So what would a data scientist do? Or if you were to wear your data scientist hat, what would you do? Well, you would kind of say, OK, the LLM judge is an imperfect classifier, and maybe I should treat finding or training this classifier as I would any machine learning model in the past. So concretely, that means taking examples of labeled traces for each failure mode and trying to partition data into train, development, and test sets. If you've been in machine learning, you're very, very familiar with this, the idea of separating your data, trying to figure out what prompt or what model works really well on your train or development set, and then making sure it doesn't overfit the alignment on a test set. So really what we found is there's no difference here with LLM applications. You still want to go through the same rigorous process. You want to make sure that you don't overfit your LLM judges. And in many classification tasks, interestingly, LLM judges, fitting them is an imbalanced classification task, which is a fancy way, there's a lot of jargon for saying that only a small fraction of the trace set is a failure or a failure mode. So when you measure alignment with your preferences, don't simply measure accuracy. Use some of these metrics that we've designed for imbalanced classification tasks, like precision or recall or false positives or false negatives, to make sure that your LLM judges are aligned. So those are 2 pitfalls. The third pitfall that we see is really, really broad, but bad experimental design, really. And I'll talk about 2 ways that we see it. One is people like to generate synthetic data. I love doing that. But they'll do so in a way where all the traces end up looking something like this. Why does that happen? Well, it's very easy to get there when you just ask an LLM for synthetic data, like give me data or 5 generic questions if you're trying to train a document question answering chatbot. OK, maybe that's not good. So how might we think like a data scientist to improve this process? We might think about ways in which we want to systematically generate the synthetic data and use LLMs for very small parts of the data generation process. So hypothesize which dimensions vary in the data that users bring into the system, generate combinations of this data, review all your synthetic data for quality, make sure there's good diversity, look at the data again. And there's a lot of different ways you can think about application-specific ways to generate synthetic data. So one exercise we like to do with people is just get into your application, look at some traces, and come up with at least 3 different dimensions that vary across users. So sometimes that's the persona of the user. Maybe they're a novice, or maybe they're somebody who's much more experienced. use LLMs to generate different values for each dimension, and then kind of, for lack of a better term, take the cross product of all of these dimensions to generate your synthetic data. All right. So that was one way in which you could have bad experimental design and generating synthetic data poorly. Another one is in designing metrics. And I talked about why we need application-specific metrics, but also how we evaluate the metrics is very important. A lot of times people evaluate metrics like score things on a 1 to 5 scale or 1 to 100 scale, and that's not very interpretable or actionable for us. How might we revisit this problem as a data scientist? Well, we'll try to make the problem as least complex as possible. We'll try to make things a binary classification problem. We're trying to ask the judge for whether something fails or not, a binary classification problem, rather than 1 to 100 or 1 to 5 scoring for something like failure. We also want to make these actionable or align with business outcomes. And really, this is really difficult to do, right? It's not going to be something that you can one-shot or get first, especially when you're trying to align LLM judges. Often we see people really struggling, even ourselves. Like, we can never write a good LLM judge prompt on the first time. But some things that help us are make these LLM judges very, very narrow in scope towards binary tasks, like passing something or failing something, and then label lots of data ourselves to try to measure alignment with that. All right. I'm going to hand it back to Hamel for the last two.
All right, some other pitfalls are, and this one happens quite a lot, is, OK, so as much as we talk about looking at data, a lot of people, for whatever reason, don't want to look at data, and they just outsource it to someone else. And one really common failure mode is, OK, let's let the AI engineer or the developers label data. And unless you're building a coding app, it's kind of a bad idea, because often those people don't have the domain expertise in whatever you're building or the problem you have. And so you don't want to do this. So most teams make it someone else's problem, but putting your data science hat on, don't trust anything. You don't trust the labels. Don't trust the people labeling the data. You make sure whoever's doing the labeling actually has the domain expertise, and then you need to look at the labels, because oftentimes there's some kind of problem in what's happening that you are not anticipating. And another reason to look at the data is this phenomenon called criteria drift. And this is from a paper, Who Validates the Validators. Shreya is an author on this paper. You should totally check it out. But criteria drift is a very simple concept. It's just they found that people don't know what they want unless they look at some data. This idea that you're going to specify a rubric up front, and that's enough, is really problematic. You need to look at data. And you really need to force people to look at the data. And it can feel like this. It is kind of like this, honestly. Another pitfall is automating too much. So you might be thinking in your mind, like, oh, all this eval stuff, can I just have Claude do it for me? And the answer is no. Claude can't read your mind. Claude doesn't know all the different product nuances of what can go wrong. Sure, there's some low-hanging fruits that LLMs can find in terms of things that are obviously errors, things that are obviously broken. But there's a lot of context that you need to externalize to get to some of the more important things often that are broken, especially the kind of more product failures that might be happening with your users. So there's a bunch of other pitfalls. We don't have time to go through every single pitfall exhaustively, but let me just give you a taste. So misusing similarity scores, okay? ROUGE, BLEU, whatever. You see that on a lot of eval dashboards, and it doesn't make any sense. Do you really want to be measuring similarity? But they come with a lot of off-the-shelf eval frameworks. I always see also number 2 here, asking the judge, is this helpful? Just really bad LLM judge prompts that are not specific to your product. Another pitfall is making annotators read raw JSON. You should take all the friction out of looking at data. So you should build your own data annotation interface that makes reading data delightful. Fourth one, reporting uncalibrated scores. So you always want to make sure, OK, if you have an LLM judge, you want to make sure you study the alignment of that judge with a human being. Otherwise, it's just anybody's best guess. You have to also be careful, number 5, to make sure you understand what data criteria drift is happening. Number 6, you want to make sure you're not overfitting your judges to data. So kind of think of it like machine learning. Like, you don't want to just take a set of data and hill climb against that data over and over, like, iteratively and overfit. You need to set aside some data and make sure that your evals are generalizing. You want to also make sure that you're sampling data effectively. And you want to make sure, like, if you're going to put a metric on a dashboard, be really careful that that metric is earning its place and actually has signal. This is not necessarily a problem just with AI. This has always been a problem, but it's definitely more acute in AI. And so if you really like take a step back, like, OK, a lot of the things that we talked about today, there's a corollary kind of skill in data science that helps alleviate this problem. So first thing we talked about, error analysis or data analysis, looking at your data. You want to find patterns in your traces. You want to make sure you're reading those traces and analyzing the patterns in them. That's a lot like EDA, or exploratory data analysis. We talked about making sure you have good metrics that are scoped to actual problems. And that's metric design. Validation, like what you would, like a model validation, how you would do in machine learning. You want to make sure your LLM as a judge is aligned with human judgment. And then you want to make sure that you are curating your data properly, your test data. And then also you want to make sure you do your monitoring and observability. And then you want to approach this whole thing with a scientific mindset. You want to experiment, and then you want to measure and try to improve. And like that muscle of being a data scientist is really helpful here. So we talked a lot today about a lot of different things. I have these skills that help you audit your evals to see if you're doing anything incorrectly. So don't worry about writing this down. I'll share a link. But most importantly, if you want to come away with something from this talk, is to always look at your data. Now, there's one question that everyone has anytime Shreya and I give a presentation is, where are the slides? Are you going to share the slides? So you can get the slides by looking at this QR code. So we'll send you the slides, but also send you all the memes. There's like a lot more memes, which is really cool. So thank you.